gonna be more complicated. All right, so we're gonna talk about trig today, but it's not more complicated. It's really like the lollipop situation, and so.
Hey guys, always remember lollipop.
Okay, so what happened is we have a chain rule, but now we're gonna apply the chain rule into the trig. So the thing about it is you can think about the situation. So what if we're just gonna want to take a derivative, a simple derivative like this one. How do I take a derivative of sine of 2x? What do you think derivative of sine of 2x is going to be?
Sorry, what's the topic of this now?
Trig derivative involve a chain rule. Cosine 2x is wrong. No.
Do we have to know one of the identities?
No, you don't have to know identity at all.
Negative. No, sorry, no, just cosine. Question.
You have to like take out
Cosine x squared. No, cosine 2. Is it right? Cosine 2. No.
you have to take out
Cosine what?
2.
cosine x.
I feel like there's a rule.
Cosine of what?
Yeah. Of something. What is it?
What?
What?
Oh, okay.
Please explain this to me.
I don't accept this answer.
First of all, there was an outer layer, just like the bubblegum layer. We're talking about there was a bubblegum layer. So in this case, 2x is within the sine functions, right? So 2x is the inner layer. Sine function is the outer layer. So we take a derivative of the outer layer, which is sine of x. So we're going to be cosine of 2x. Material inside is still the same. The inside is still bubblegum, it's still 2x. Then you're going to take a derivative of the inside, which is 2. Does that make sense?
Yeah.
Okay, let me give you a harder one.
I'm sorry. So when you did this, yeah.
Trying to figure out this one.
Okay, let's take a derivative of this one. Be careful how this one works. If I take a derivative of cosine times 1 minus x squared, and think about what is the layer. Draw out the layer, what the outer layer and what the inner layer is. And then you know how to take a derivative of this, because this is much easier than you think.
Is it not?
Can we just make that u and then do the whole?
Yeah, you just have to simplify it.
Simplify or? How do you do it?
Just the negative sign and negative sign times together.
So Mr. Ye, when you did the derivative of the outer layer and the top
Put
one,
2x in front.
Which is the cosine of a...
So the outer layer included 2x. And
Yeah,
2x.
yeah,
And then you did a derivative of the inner one.
yeah, just like a lollipop.
Can you put the
Yeah,
2x in the
just
front?
like- Oh, okay, okay.
You can put 2x in the front, it doesn't matter. So, shh.
Mr. Is this right?
So it's either a sphere.
Yo!
Yeah. So if I take a derivative of this, it's gonna be sine negative sine of 1 minus x squared times the derivative of inside, because there was 2 layer here, and then there's gonna be negative 2x. And if you multiply that, that's gonna give you what? 2x sine of 1 minus x squared.
Oh, you were supposed to do that.
That's it.
Dang it.
How about derivative of a secant of 3x?
Remember that awesome analogy, everyone.
That's how I use all the time.
Like every day I use it for calculus. If we need to use it.
That's how I use it. And I just do shit.
I'm proud of you.
Hold on. We're gonna go over it, don't worry. You guys still done?
Whoa, hold on there for a second.
What do you mean that's the-
Right there.
No, everyone's a genius.
I don't even know that.
Like,
Does 10
what? Oh, I was listening
You guys got that?
Yes.
Because the inside is still 3x, it doesn't become x, okay? So those are the things that you guys should think. Now, other thing is about the parentheses. So I want to talk about the parentheses part. The parentheses part is actually very crucial. A lot of you guys need to understand the parentheses. So if I have a cosine of 3x squared, and the y equal to cosine of 3x squared, and the y equal to cosine of 3x squared. Do you see how I have first one no parentheses, second one a parentheses, third one is a parentheses, but they all sound the same when I read it out loud. Okay? And also y equal to cosine square of x, and y equal to square root of cosine of x. So those are 5 situations that each one is a little bit different. Each one I will rewrite it. We gotta be careful. What's the difference between the first one and the second one? The 3 gets a square too. Thank you. So this one's still cosine 3x. This one's a cosine of 9x squared. Does that make sense? Because the parenthesis of the 2 is affecting the 3 just as well affecting the x. This one is actually it's called cosine of 3 is just a constant. It's a number. Cosine of 3 roughly like 0.99. The reason why I know is cosine of pi is 3.14. Cosine of 3.14 is -1. So therefore it's very close to the second quadrant, very close to the x-axis. So in this case, if I just write it, I'll still write it as a cosine of 3 of x squared. And then this one I'll write a cosine of x squared. And this one I'll write down the cosine of x to the 1/2. Now I'm going to do is take a derivative, y prime. What's the derivative of this case? Cosine of 3x squared. So this is a parenthesis right here, right? If I didn't write any parentheses, that means cosine of 3x squared. So what would it be?
Negative sine x.
Negative sine
times
x.
3.
Negative sine, not x.
Negative sine 3.
3x squared times 6x. Because the inside stay the same. What's the derivative of the second one? Well, it's roughly the same, right? This is 9x squared, right? Times 18x. Does that make sense? So even with a parenthesis, they look like almost the same, but they are completely different. What will be a derivative of the next one? This one's kind of tricky. Yep, it's 2x, but you forgot something.
What happened?
X squared is 2x times cosine of 3. Cosine of 3 is still there. Yeah, that's a constant.
Wait, cosine is
Yeah, so think about your derivative of 3x squared, which is you left the 3 alone, you take a derivative of the x squared, which is 2x, times 3, which is 6x. What will be a derivative of this one? No. Nice try though. No. What? No.
It's 2
Nope.
cosine x times negative sine x.
There you go. 2
I don't know.
cosine of x times the derivative inside, which is negative sine of x. And it's actually a double angle identity right there. Okay, so how about the next one?
1/2 cosine x times negative sine x.
Yep.
Sorry, how did you do the previous one? Oh, yes. No, that explains everything. Thank you, Jen.
No, that's right. It's this one right.
Okay, are we okay here?
Wait.
Now we're gonna get rid of the super challenge question. They're not challenged, but you have to know all the derivative. For me, this one, derivative of sine of x equal to cosine of x. Derivative of a cosine of x equal to negative sine of x, right? We know this. Derivative of dx of tangent of x is equal to what? Secant square?
Secant square then.
D to the dx of cotangent of x. I'm live streaming, so.
Oh.
Can't say that word.
D to the dx of secant of x is what?
Secant tangent.
Secant.
AKA.
D to the dx of cosecant of x equal to negative, so this is all negative.
Negative.
CSC of x, COT of x, right? So now we know this. Now we're going to implement all this, but we're going to take a derivative of this function. So it'll be tangent to the third power to the sine of CSC of 3x. So, okay, so now pay attention. There was a layer. There was a few layers. This is like a 12-layer cake. No, actually 5. But there was a 3x is inside. There was a cosecant. Cosecant 3x is within sine. Sine of cosecant of 3x is within 10. And the 10 of sine of cosecant of 3x is within x to the cube function. So technically, I will rewrite this as this. Tangent of sine of cosecant of 3x. I think I got too many parentheses. To the third power. So I will write down to the third power. Now I will write a layer from here. So if I write a layer, it's going to look like this one, the first layer. And this is the second layer.
Are these steps?
This is the third layer. This is the fourth layer. And this is the fifth layer. So I will layer all this individually. Now, what I will write out is going to be really long. Is I'm going to take a derivative of the x to the cube, which is 3x squared. In this case, is 3 tangent squared. So 3 tangent squared. But inside material is still exactly the same because we haven't touched them yet. Okay, so now we're going to times the next layer, which is tangent. What's the derivative of tangent? Secant square, and the inside is still the same. And then what's the next layer? The sine, which is the cosine of cosecant of 3x. What's the next layer? Cosecant. What's the derivative of cosecant? So we keep this the same. And then what's the derivative of the inside? And that's it. Oh yeah, that's it. And then I will simplify this to negative 9 tangent square of sine of CSC of 3x. Because this is 3, this is negative sine, this is 3, this is negative 9. Times secant square of sine of CSC of 3x times COS of CSC of 3x times CSC of 3x and times COT of 3x, and that's it. Yeah, that's it. Okay, so you're going to take a derivative of this. Sine to the third.
Hold on.
It's okay. You got this. You got this, okay?
My brain.
I don't slow down. I'm going to go faster.
You know, I'll take a picture.
How
Keep
do we
going,
go
it's
from
okay.
this to this?
Don't
Let's
scroll.
escalate it quickly.
We're going to take a derivative of this.
No way you're
I
writing.
still look at the person that.
Cotangent.
No.
Yeah, take a second derivative. Good luck.
Don't make
Oh my god.
I quit.
If you do that one.
Yeah, please don't do that.
I was say taking second derivative. Just kidding.
Take it through this. It's the last question. Then at the bottom, when they have
Is that a hard one?
fine print, this is just a practice.
I'll be going for possibility.
Is that a hard one?
No, this is the easy one.
I'm still writing down the other one.
There's so many parentheses.
No, quitting calc.
It's like computer programming. A lot of parentheses.
Is like the
Oh no, there's far fewer.
This is the simple.
Far fewer.
This is much more.
Is that on the computer science you have to close the parentheses, right? You have to close all the parentheses, right?
Yeah, there's brackets and parentheses, but there's never that. This is just hell.
This is not hell. This is easier than computer science. I can never do computer science.
Hey, maybe the homeless lunch tomorrow, you'll get multi-layered lollipops.
You can just leave them.
Can I use a script on the
Yeah,
test?
you can do it.
A script?
That is correct.
What?
Okay, so 3 sines square of tangent of 3x, and then cosine of tangent of 3x, and then derivative of the inside there was secant square of 3x times 3. So times 3. So this one will change it to 9. And that's the final answer.
Why did